and we use code 4069535 to run the quiz. And as soon as you join, please push thumbs up, so I will know what we are here together and we can start. Something weird happened to YouTube from my side. I don't know, I have no reviews in live chat. And I see no thumbs up on menti.com. Okay, someone is here already, that's great. So at least you can hear me, that's great. Yes, finally. Thank you so much. So, very well. So I will not wait for too long because we have a lot of content today to cover. So I will ask those who joined already, but at least it looks like, okay, YouTube is back online. Very well. So let's start with the questions. Don't forget, we soon run quiz using Menti, but now it's not about quizzes and prizes, but now that's about just answering questions. My first question here is, did you attend Docker Learning Path or join it just for Kubernetes? If it's for you session number 5 or session number 1. Okay, so most of you attended previous classes, which is great. I didn't. I'm here only for Kubernetes. Is also good as long as you have understanding how Docker works. You are very welcome. And if you don't, this course is still open, so you can completely watch any part of those videos later on YouTube. They all are recorded and available for free. So, okay, that's great. Then, next question. That's mostly for those who were attending course. Have you started using Docker outside of the course? I've asked this question before, and I started today again because that was still whole week, and I want to see. I started to use it at work. Yes, these kind of best answers. It always makes me happy to see you practice the knowledge we give, and you start to use things live. That's incredible. I didn't start yet. Don't worry. Take your time. I used it before course as well. Okay, I hope we brought some useful knowledge to you. Also, I started to use it for personal project. I started to use it at work. Perfect. That makes me absolutely happy. So, and finally, what's your experience with Docker? Don't forget, today we have people as from the course, but also newcomers. So that's important for us to understand how much experience do you have and how deep we can dive together into this Kubernetes workshop we are doing right now today. And I see we have people with different experience, let's say. If you have real practical experience, that's always the best. If you have seen this Docker Learning Path, that's also good. Only video from Docker Learning Path. Well, okay. Although you really can learn something only putting your hands on that, and no experience at all. This workshop may be a little bit overcomplicated because Kubernetes is a container orchestration tool, and that's hard to learn Kubernetes if you don't know what the containers are and how containerization works. But again, don't worry, that's completely fine. If you just don't feel comfortable during this workshop, you may need maybe to repeat, to play one of our previews from the Docker Learning Path from DataStax Monday Learning. And that's it to set up, and we can proceed finally and go to Kubernetes. Don't close Menti. You will need that for the prizes and for the quiz we will do later on today. And as we have not so many people right now, it means what everyone who is with us has higher chances to win the prizes. So I congratulate you anyway. Okay, well, so let's move on. Container orchestration. In general, Kubernetes is a container orchestration, container management tool, but first of all, orchestration. So what does that mean? If you attended our first and especially second week of the learning path, you know what container management can be hard, especially at scale, especially when you start to run some of them. There are a lot of things to consider. There are all those Docker create, Docker run, all those volumes, and so on and so forth. As a result, even for free containers only working together, you have to execute very big commands, and that getting much worse. Then you have more of them, and mostly probably, especially on production, you aren't going to use 2 containers. You are going to use much more of them. So at week 2 we discussed Docker Compose. Docker Compose was our first container orchestration tool. It's much easier, much simpler than Kubernetes, but still very useful. Despite container orchestration, Docker Compose is a great thing. It also doesn't fit into the production purposes. It's just not developed for that. It's not like it's bad, it just doesn't fit the use case. It goes very good for testing purposes, some of them, and goes very well for development purposes. But what if we speak about much higher numbers? What if we speak about thousands of containers, maybe thousands of containers, over hundreds of servers? Kubernetes was originally developed in Google, and it was developed to fit Google scale use case. That basically means a lot of servers. And how do we manage with this size of the deployments? We need a container orchestration. Why exactly we need a container orchestration? I will give you more scientific explanation in a second, but I also would like to give you a little recommendation. I will copy paste the link to the chat. Not right now, please stay with me, don't quit, but you will need that for the future. That's a great comic about Kubernetes and new adventure of Jason Yazon. Don't know how you speak that in English. And that's definitely a great story in more comic way, explaining why do we need container orchestration. Oh yeah, thank you, Cedric. I did that too. Yep. So, but speaking more scientifically, what are the purposes of container orchestration and which kind of work container orchestration does? So, there are a lot of different things for some of you. Some will be more important and maybe some not so much important. So in kind of random order. First of all, deployment and provisioning. If you have, for example, a real experience with Apache Cassandra, you know what we don't start the whole cluster altogether especially when we deploy a new one. We first run one node, and then we have others to join. And that's just a first point in the long list of different considerations you have to do if you run applications. Some will require some special provisioning. How to deploy them? If you have 5 servers, you don't want service A to be deployed only in 5 instances, let's say on one of the servers. When as soon as this server is done, is broken, dead for any reason, all of your instances of service A will be not available anymore. So also deployment and which part to put where to have highest possible availability. Things like that. Deployment and provisioning purposes. That's one of the concerns of container orchestration. Then, up and down scaling. That's not the easiest situation. There are some, again, special consideration. And when you work with just plain Docker, there are a lot of things you have to do manually. In this case, we may speak about more automated process, again considering all the deployment and provisioning steps. So it's much better automated. Health check monitoring, of course, in general, and self-healing as well. So if one one container, let's say for the moment, if one container returns bad state regularly, then maybe it has to be terminated and we may need a new one if something is wrong with the old one. Load balancing, of course, doesn't matter if you have 5 or 10 instances of service A, but if only one of them receives queries all the time and others are idling, obviously that's not the best case scenario. So we will need a strong load balancing, and that's also job what Kubernetes does for us. When we go for resource management, so how many of the nodes with which kind of load we want to have and how to balance load and utilize our resources properly. Don't overdo, but also don't be too relaxing, like it will be just too much costs for the company and we are trying to count money. Routing and publication. Routing means what every service must be able to reach another service to execute some query. And as pods are ephemeral, if containers are ephemeral, today we have 5, tomorrow 3, and on different machines, you cannot just use IP addresses. They're kind of moving, migrating from node to node. And no, that's a bad idea to try to stick them to some particular nodes. That makes application fragile by design. It's much better to use proper routing. And Kubernetes has a real domain name server inside to help you with routing, so you don't care about the real allocation of containers over the cluster. If you want to reach service, you will be able to do it without thinking where is it located. And publication as well. We want to be able to public our services, so they will be reachable, and that's of course very important. You don't want to use an application you cannot reach, and your customers definitely will not be happy. When we think of service discovery, especially when we speak about microservices, service discovery is very important. So you don't want to manually explain to every service where to find its colleagues and how to communicate this action they do together further. Service discovery is an important part. Also, configuration management. Containers will need different configuration in development, staging, and on production. And that's very important. What every container will receive for configuration it needs to be executed properly in the environment it runs right now. When secret management, it means passwords, API keys, and so on and so forth. All of that should be dispatched on time, kept in secret, and available for the container when it starts. And there is a lot of work. This is a picture of management console, let's say, of a U-boat, German submarine. And sometimes trying to manage a lot of containers without proper tools looks exactly like that. You need to pull some levers in some specific order, and if you make a mistake, your server, your cluster may swim too deep as a submarine could. So our suggestion, without orchestration, you would you try to avoid managing that manually, as long as there are special tools, especially such great tools with open source routes are available for you to run. Before we proceed with Kubernetes, just a couple of words about if there is some kind of a competition or not. In short, of course, there is a competition, but there are some container orchestration options, but as soon as we start to speak about them, in the final end, we find out ourselves what Kubernetes is still the one and main option. Kubernetes makes over 90% on this market, and that's for real. When it's all started and container orchestration things were in huge demand, only Kubernetes was something more or less usable and covering most of the use cases. By those times, Docker Swarm was just not production ready at all, and feature rich. No way. It was like feature empty, just a couple of minor things. Docker Swarm was too late on the market. By those days, Docker Swarm is much more adult, let's say, but there are still some downsides. So for smaller projects, you may be good with Docker Swarm, but if you run something bigger, you just have no other options with Kubernetes. Helios, developed by Spotify, is deprecated, and they are migrating to Kubernetes as well. Helios could have been a good project, but again, he lost this war to Kubernetes. Okay. So there are one more thing about competition to discuss. There is 3 main ways to use Kubernetes. You can use your own infrastructure on premises, and you can manage your own instance of a Kubernetes. You may use cloud infrastructure with Amazon EC2, for example, or Google Compute Platform, and still use your own Kubernetes, but virtual instances for them servers from the cloud provider. And finally, you can use managed Kubernetes on managed machines, like with Amazon Elastic Kubernetes Service, Google Kubernetes Engine, Azure Kubernetes Service, and some more. I will not mention everyone. Main difference here is who manages what. Or when you host everything on premises, you have to manage infrastructure, Kubernetes, and application. Using hosted infrastructure like any kind of a cloud, like AWS EC2, you can install your own Kubernetes over that, and it will perfectly work, but you still have to manage Kubernetes, install updates, and so on and so forth. And for some companies, it may be a better way to go with managed Kubernetes, so you will have infrastructure and Kubernetes, like with Google Kubernetes Engine, and you will have to take care only of application. Which one is better? That's only for you to decide. So I don't know your use case. That's very, very depend, but yeah, definitely need you to know what there are some options, and something may work better for you than another. And by now, as long as we have no questions, we are ready to go with the Kubernetes Fundamentals. And that's great, because that's why we are here. First, we still need servers. Of course, we need some machines to run our application. When we speak of Kubernetes, we first speak of 2 kinds of nodes. So servers, from Kubernetes point of view, are the nodes. And there are 2 main kinds of nodes, master and worker. Master is the management. Usually they aren't so big, and they needed to schedule job for workers. And workers are big, powerful servers. Those run your containers. The word container on the left is, well, we will discuss it. It's not really containers, but pods. And finally, on the right part of the picture, you may see etcd. etcd, if you maybe know, it's a database, kind of pretty simple one. We can use that for, well, Kubernetes uses that to store configuration and many other jobs. But that's more about operations course with Kubernetes, so we will not mention it anymore. But in general, yes, that looks like that. Some master nodes, some worker nodes. Typical worker node we will cover looks like that. We have pods running in worker nodes. And what are the pods? That's the final step of the 5 weeks course, and I've never mentioned pods before, you would say, and you will be perfectly right. That's because pods is a very Kubernetes specific thing. we can consider pod as a wrapper for a container, or container for containers. I mean container for Docker container. Usually pod contain one container. In some cases it may have more, but usually not too much. So what is it, how it works, and why do we need that? First of all, why do we need that? That's important to understand. What Kubernetes may work not only with Docker containers, but for example with RKT containers or with some kind of special virtual machines as well. Pod allows us to abstract from the, is it Docker container, RKT container, virtual machine, and have just a running entity, which is a pod. Consider pod as just a wrapper, like your container is in a package. And that's how Kubernetes handles them. Now, why do some pods may have one container and some may have more? In general, in most of the cases, every pod has one container, and that's a good practice. Why we would need to have two? Some containers want to be very shoulder to shoulder to another. For example, if you run Apache Cassandra, as mentioned before, you would see what Cassandra pods have two containers instead of one. Why? Because one is Cassandra as it is, and second one is a sidecar management process which works together with Cassandra, and you can ask it for some statements, if everything is fine with Cassandra, what's the process inside, and so on. So they want to work shoulder to shoulder, and containers within one pod has a lesser isolation one from another. For example, in this case, pod on the left can communicate with pod on the right only using normal network operations. But container in the pod right upper container may communicate with a lower container, for example, also using inter-process communication, IPC. So lesser isolation from each other. And there are some more changes. How to decide if you may want to have multiple containers in a pod, or you are fine with one container in a pod. I prefer to think, to solve this, to answer this question, I prefer to think of scaling. Imagine you have container type A and container type B, and you think if they should live together in a single pod, or if they have to live in different pods. Think how you would scale them. For example, you had 3 of A and 3 of B, let's say, doesn't matter, and now you want to have, now something is changing in the system. If you always want to have them in the same numbers, like if you want container type B to be as much as container type A, always, then mostly probably means they can be a good neighbors, because pod is the smallest unit we can deploy, scale up or scale down. And if there can be situations what you want to have 3 container type A and 20 containers type B, then mostly probably they will be good living in different pods, and that's also very good. Good. Now let's make a bit deeper step into a pod. So as we know, pod is a containerized container, and it also has some special metadata and some special labels we may see a bit later, and 2 more things which are very often used with pods, so we have to remember that, are secrets and config maps. On the right part of the picture you see secret icon and config map icon. What are those? So, as I said in the beginning, Kubernetes manages secrets and configuration for us. And every pod, every container has to receive some data to operate successfully. Password, how to log into database. Configuration, how exactly this application has to be executed, and many others. So we can first create config map and some secrets, and when we are running pod, we are attaching them to a container, so container will use them. And finally, pods management. We can manage pods directly, manually, like before we did docker run container from image. Now we say kubectl, kube controller, create pod. But it will be basically the same. Now we have one more abstraction layer, but we still have to manage that. So if we want to have it more flexible, then we may need one more thing. And with one more thing will be deployment. Deployment is a configuration. Deployment is an abstraction which allows me to describe the deployment of pods I want to have. So, for example, instead of manually running those pods, I describe a deployment. Don't worry, we will work with a deployment file soon, so you will see how it looks like. And I may say what I need. For this deployment, I'm using this template for my pods. I'm going to have, for this moment, 3 replicas, and that's the configuration we are going to use. So deployment is a configuration or abstraction for us to define groups of pods. There is a, first of all, I'm sorry, YouTube updates very slowly to me, so I think I maybe missed a question. Abhilash asks, can I control how containers are combined in pods, like container A and C grouped together in one pod and container B in another pod? Yes, absolutely. We will see it in a moment in the configuration files. Okay. So, deployment describes groups of pods and their configuration, desired state, count, settings, and so on. Based on your deployment manifests, your deployment definitions, deployment controller will create a replica set. Those will scale pods up and down depending on your settings for scale. It may sound bit weird because I didn't mention replica set before, and that's absolutely intentionally. The point is, now replica set is considered too low-level management unit, and in general that's not recommended to touch them at all, and you don't recommend it to think of them too much. Create the deployment, and deployment controller will create replica set for you. Delete the deployment, deployment controller will remove replica set for you. Don't try to communicate with them that just too much. Just set in the deployment settings for your deployments, like how many replicas of this pod you want to have. Now, we are getting closer to some interesting things. How do we manage Kubernetes? So there are, in general, 2 approaches and 2 ways to discuss. First one is simplest one, direct. So you have kubectl, kube control tool. That's just a console, simple console tool, which gets your arguments and makes API calls to the Kubernetes API server and make changes. So you just run a command and Kubernetes will do something due to the kubectl request. For example, let's take a bigger, closer look at the third example. Here we go, we create a deployment. First we ask kubectl. Second, we tell what to do. Create. Create what? Deployment. What will be the deployment name? My-dep. My deployment. Then image. We will use image Nginx. By the way, if you have been there 1 week ago, you know what, that's not a best practice to use latest image, but you have always specify at least major version. But okay, that's for demo purposes, it's fine. We use image Nginx. And how many replicas we are going to have? We are going to have 3 replicas. Based on these commands, kubectl will create a deployment, my-dep, image Nginx, replicas 3. and we can see how it will work actually. So that will be a good place for us to start. So there are multiple ways to use Kubernetes. I mean, not for production purposes, but more to learn how to learn that. You can install locally Minikube or Kind. I will show in a moment. And if you don't want to install anything, or you can't have Docker, then you could try to use labs.play-with-kubernetes.com. That's the link. And to contact that, you will need your GitHub account or hub.docker.com account. That's in general very simple thing. That's Kubernetes Playground. Servers are pretty weak. All instances will be terminated after 4 hours, but that's completely enough to play some games. So first of all, I'm going to add a new instance, and it's here. Then it has everything installed, but not Kubernetes as it is deployed yet. So I have to initialize cluster master node, first one. It will be kube admin init, and how exactly I'm going to init. Again, that's not an operations course, so that will be enough for me to start. But I will not make a deeper dive into that. And I will need one more instance. Good. So it takes a moment to initialize Kubernetes, but that's very fine. While it initializes, to save some of our time, I will tell you a couple of words about how you run Kubernetes locally. So there are two main ways. Minikube. So github.com Kubernetes Minikube, good project. I've used it a lot of times before. A very simple one. You just install that as explained in installation step. That's a very short one, and you have your Kubernetes running. The only problem, Minikube supports only one working node. For some of the cases, as we at DataStax work pretty a lot with applications which require true distributed architecture, we prefer to use Kind. Kind, literally means Kubernetes in Docker. That's a pretty funny story. Kind is Kubernetes and Docker special project from Kubernetes, which runs special containers in Docker, which think they are Kubernetes nodes and behave like Kubernetes node. And that's a little bit funny, like about a crisis of self-identity, if you think about that. There is a container thinking it's node. Nope, it isn't. But still, it works exactly like Kubernetes works. And that's a very great thing to use if you have to work with exactly multiple nodes, multiple distributed nodes application. This Kind may be a very good way, better than Minikube. Okay, so how it goes for me at Docker Playground? It looks like we are good at node 1, and first one is over. My cluster is not yet finished. I have to do one more thing. I have to initialize networking. Otherwise, networking will not work for me, and of course, my pods will be not able to communicate. Okay, so this one was quick. And finally, now, with the information given here, I can initialize a worker. When you start deployment of a Kubernetes with kubeadm, it prints how you can join new nodes to this cluster. So I simply copy-paste that. It's prepared. It consists like which IP to join, which port to use, secret token, and so on. And I go to my node tool, and I tell to join this new cluster. And it will take a moment. And for example, now on my first, No, don't reload. At my first node, which is a master node, I can say kubectl get nodes. And I have two nodes at the moment, master, which is ready, and node 2, which is not ready, because there are some special processes coming. It's only joining the cluster. And actually, you know what? I will use one more node, so I will have two workers. Here we go. And this one will join as well. Okay. So I want to see how it goes. I will go for watch kubectl get nodes. Okay, so first node is ready, second node is ready, third node is starting up. Very well. Now let me ask you a question, and that may be not that's a question with not obvious answer. Do you think we have how it goes for my nodes? Okay, that's why labs play with Docker is maybe not the always best choice, but usually it works pretty well. So my question is, if I run the command kubectl get pods, will I have any pods there or not? An answer is not obvious. From one point of view, you may think you never started any of them, so therefore you shouldn't have any. And answer is yes. At least it should be yes. It looks like something is wrong with the first node. Oh my god. Okay, I will try to show it locally. I have created a kind cluster with kind. It will do the same job. And if you wait for a moment, I will move myself so I will not close the content. And I see an answer on YouTube, there will be no pods. That's a partially correct answer. So I indeed, at the first, it's something really wrong with this node. I will try to restart that. Okay. It looks like I cannot restart that. Oh my god. Ready. So kubectl thinks they are ready. Finally. Okay. So, and at first answer looks like no, we don't have pods. But as I told you, that's a partially correct answer. Because, thank you, close the session and start a new one. If I would close the session, I will never be able to recreate that in next 3 hours, 52 minutes. I've tried that already a couple of times today. So, better not close session without a really heavy reason. Okay, good, so we are fine. At first we see there are no resources found in default namespace. No pods. But there are a couple of secrets, because I can also do it like that. All-namespaces. And now it looks very different. So what are all those pods? Who started them? Answer is they are located in the namespace kube system. Take a look. When you work with Kubernetes, mostly probably it means you're going to have a lot of containers, a lot of pods. And problem is, in some cases, maybe like 100,000 of them, maybe 100 million of them, I don't know. What's your scale? Docker and Kubernetes are heavily used all over the world in the biggest companies. So we use namespaces to separate container pods of different purposes. Not only pods, but also all the other resources we discussed. So kubesystem namespace is a system namespace where we run containers, pods of a different purpose. And I want to show you a couple of things. So first of all, I want to print more data. To do it, I will do -o wide. So I will have the bigger output. I will have more things here. First, I will make it a little bit smaller so it will fit to a screen. Good. And now I want to do a little grep here. I want to see my node 1. So very well. Those are the containers, or those are the pods running on my node 1. And what's that, and why so much? Why so much? Let's take a look. First, core DNS. I told you Kubernetes provides a very strong support for routing, service discovery, autoscaling, and so on and so forth. That means your services have to be always able to communicate with each other. Core DNS makes all the domain name. It's a real domain name server, like exactly like your browsers uses. Then you go and open YouTube. That's the thing. How it works. Then etcd. I mentioned it before. etcd is just a database for Kubernetes to work with. Then kube API server. That's pretty simple. That's the API server. So when you do kubectl apply or something, kubectl will call API server. Then controller manager is the main brain, and everything what happens with the decision of a controller manager. When we have proxy router, we will discuss in a moment. And finally, scheduler. We use scheduler to schedule pods. When you create a new pod, it needs a node to be to run somewhere. And create is maybe too straightforward definition. Kubernetes people prefer speak schedule. So we are scheduling a pod to a node. And this scheduler is basically job is to schedule a pod, and therefore it needs to understand what are the nodes, which one is loaded, where are they located. So maybe put our pod not to node 2, but to node 3, and so on. And what happens if I require to see all my pods, but from the node 2 or node 3? It will be the same for both of them. There are only two processes. So, why? Because they are worker nodes. They are usually more powerful than master nodes. And they do the main job, they run the pods. And to run the pod in the minimum configuration, they need kube proxy and kube router. So what's that? Proxy and router work together, and they needed to define how to route a request. Kubernetes uses, as Docker does, Kubernetes also uses so-called software-defined network. And when a query comes first to an ingress controller, for example, of the Kubernetes, we will cover that some slides later. It will calculate which pod to ask, and therefore which node to ask, because pods are running on nodes, and it sends query, and then proxy and router here are to accept this query, accept this call, API call, and route it to the proper pod. So far, as you see, we run only kube system pods, but we don't run any useful workload, let's say. Let's take a look at what could we do to run something. And first example suggested for us to run by playwithkubernetes.com is to put a file, to apply a file. So let me get back to this moment. There are two ways to manage Kubernetes. You can give commands with kubectl. Kubectl create deployment name, deployment image, deployment replicas, port, and so on and so forth. Does that work? Yes, of course. But there is another way, which may be much more interesting to you, especially when we speak not about test environment, but about production. This approach, call it infrastructure as a code. The general idea is you define what do you want to have, and then instead of explicitly say kubectl create deployment, you say kubectl apply file. And then what's the value? Why it may be better usage for you. So you always have understanding of your infrastructure even without asking code, especially if you keep these files under Git. I'm still under a non-disclosure agreement, so I can't tell you a whole story, but I can say what were some nice, some situations. We were really happy to have our infrastructure as a code, and my former project, one of my former projects, and it was just incredible to go and see, like, okay, 1 month ago our infrastructure looked like that, and that was a change, and that was the change. At this point something weird started to happen, so we were able to investigate step by step all the changes into our production infrastructure, although it was pretty big. So keeping your configuration in files, it's very convenient, and infrastructure as a code is a cool approach. If you have heard something about Terraform, for example, it's also a great thing, but it doesn't relate to Kubernetes, so I will not speak about that today. So let's take a look what we are going to do now and why I'm speaking about that right now. Answer is I'm doing kubectl apply -f, and then there's a long line file location. That basically means what I'm applying a file. As you see, this file is located not locally. I can download that, of course, and use it locally, but this file is located in the repository Kubernetes website example application, Nginx application. And before running that, it's always a good idea to open that and take a look what we are going to do. Of course, I hope it's big enough and you can easily see that. So here we have definitions of two different units, two different things we are going to work with, located into one file. Personally, I prefer to keep different things in different files, but in this case, as for educational application, it makes a lot of sense. So first two lines of a configuration file you always have to consider are the API versions and kind, and they both matter a lot. And here later you can find the same API version and kind. We have two units here we will work with. First one is API version apps/v1 and kind deployment. What's the deployment? You know already, I told you deployment is a group of pods sharing configuration, replica set, and so on. So in this case, first property we want to mention is metadata. This deployment, when we create that, will have name my Nginx. We can change that, of course, and it will have label app Nginx. That's a very important thing, labels and selectors. They are used a lot in Kubernetes and you do have to understand them. So I will say, I will explain that later in bigger details. And then finally we have a specification. As it's a deployment, one of the important specification parameters, replicas. So how many pods we are going to have. Then selector. What is that? How we are going to match them? They will have label application Nginx, and that's the template for the pods we are going to create, and that's the whole template we are going to have in the end. Those will be pods with label app Nginx, so app key Nginx value. And their specification will be every pod will have only one container. Name of this container will be Nginx. They will use image Nginx 1.14.2, and container port needed for the connection is port 80. Very simple. And next one is a service. So let me jump back to the slides and show you something about service before we proceed. Kubernetes networking. Of course, as Kubernetes is supposed to run on multiple servers and multiple pods isolated from each other, networking is a big thing. So, we have two main things in networking to consider. There are more, but we have only 2 hours today, so I cannot explain every next step. First point we need to have: service. Service mostly used for internal communication. Service is a network abstraction used to expose an application set of pods as a network service. Easier speaking, service is a facade for the group of pods, for example, deployment, which provides some network name and load balancing. What's the trick? Today you have, let's say we speak about deployment A, and we will call the pods of this deployment A, A1, A2, A3. What will be their network names? Something like A1, A2, A3, and so on. And let's say pod A1 is broken, pod A2 is not responsive, and Kubernetes starts pod A3 and pod A4. It means what the application which works with them needs now to call not pod A1 or A2, but pod A3 and A4. Question is, how do you going to inform client it's going to use new addresses? There is no simple way to do it. Of course, we can contact pods by their names, but we should not do that because there is a better way. So service. Service is a facade for pods. You have a service, call it service A. This service knows all the pods those belong to this deployment, for example. And then when you do any query from another service, from another pod, pod B, let's say, pod C, it will not ask pod A1 or pod A2, but it will ask service A. And service A will do a load balancing to throw, therefore, this query to one of the pods, for example, like a round-robin load balancing, the last contacted pod. Very simple. And as a result, you can use just a service name as a final address, and you don't care about how much pod you have, pods of this type you have running right now, as long as you know the service ID, the service name, you will be able to contact them. Very simple. So I'm jumping back. So as you guess, here we're defining a service. It will have API version v1, kind it's service, very easy. Metadata, so it will have name my Nginx service. SVC is just an abbreviation for service. It will have labels up Nginx. And here the spec, and that's important. This spec will have type load balancer, and we will have ports 80, and selector will be up Nginx. So I told you service is the facade for the group of pods. Now, how does Kubernetes decide which pod belongs to a service? Due to selector. And here we see select up Nginx. It means what this service will be a facade, a front end kinda, for router for all pods with label key up value equals Nginx. And indeed, if we go here, we see metadata label up Nginx, that's for deployment. Well, service doesn't work with deployment as it is, it works with pods. And finally, we see in the template of the pods we are going to create, we see metadata labels up Nginx. It means what every pod, every three of pods, as we see here, to be created, we will have therefore all of them with label app nginx, and this service will work for all of them. Good. So that should be enough. Let's do it. It goes good. So now we see what we have: service my nginx svc created and deployment apps my nginx created. Now we can do some job. First we can do kubectl get pods. Oops, pods. Very well, we have 3 pods running. If I say -o write to have more data, we will see what they're spread over the cluster. So notice they have node 2, node 3, node 3. And that's basically a very simple idea. So we have 2 worker nodes, and Kubernetes spreads them over all the available nodes, as long as we don't have any affinity specified. But that's not the point. Now, what else we can check? Now we can check also deployments. I will simply type deploy because Kubernetes allows to use aliases instead of, because just deployment is too long and I'm lazy, so I will say kubectl get deploy. We have 1 deploy, nginx, ready, free of free, up to date free, available free, exist for 1 minute. And finally, the last thing we can check is services. And I again will use alias. I can type kubectl get service or kubectl get svc. That's exactly the same. And now I see I have 2 services. Why 2? Very simple. One is Kubernetes as it is, use it to communicate with Kubernetes, and the second one is mine newly created my nginx SDC type load balancer. No external IP available at this moment, and it serves at port 18. So that's we just created a deployment service, and it works for us very well. So we can move further a little bit with the slides. So we discussed service, and as said, service is mostly used internally. So well, then what's then used externally? First of all, we can expose service. There is a way. We can say what service has type node port, and it will work. But it's not the best strategy because node port is a special case. You definitely do not want to use it on your production. And in general, we try to avoid that. Thing we prefer to use is called ingress. Ingress is an entry point for external connections. It's a router what accepts incoming queries and routes them to a proper service based on the defined rules. For example, typical use case with ingress, if you have ever configured Apache Web Server or Nginx, one of the most widely used way to configure routing is based on the host name. And it means what if the Kubernetes ingress receives a query with host name, I don't know, application a.com, and ingress knows what application a.com is served by service A, it will dispatch these requests to service A. And if we have query for application b.com, and ingress knows about that, of course, you have to configure that, then ingress will send this query to service B, as it knows this service handles these kind of queries. So, that's the main part of communication with external and publishing ports to be available for external clients, not internal clients. Then, Kubernetes persistent data. So, it's not so easy. You remember maybe before using Docker at the class in the second week of the learning path, we used volumes and bind mounts. So in this case, it's a little bit more complex. I will not make a too deep stop on that point, because otherwise we will spend here next 5 hours, and mostly probably you don't want to do it. So I will explain that shortly. First thing, we think about working with persistent data, what data we want to persist, like database data. In Kubernetes, they will require a persistent volume. Persistent volume is has a storage class, and I will start with a storage class. Storage class is something what defines what exactly and how exactly we access our storage. You remember we were using volumes in the week 2, but what those volumes, basically they were just simple folders. That's just normal folders we bound, for example, with network file system. It depends on your Docker installation. But it's not always like that. If you are working with AWS, you are mostly probably going to have EBS storage. If you are working with other kinds of clouds, you may going to use some of this cloud specific thing, like for Google Compute Platform, for example, or it may be some network attached storage, and so on and so forth. They will require different storage classes. And different storage classes are base to create different persistent volumes. As you have your persistent volumes ready, your pods may have persistent volumes claim. What is a persistent volume claim? That's basically a request to allocate a persistent volume to this pod. If this claim can be executed, so you have enough persistent volume things to dispatch a persistent volume to this pod, well then that's executed and your pod has a place to store that. I will not make a deeper dive on that. If you work with local files, it will be again just with normal plain Docker. It will be just folders, mapping and bind mount. But if you use something more advanced, if you are in the cloud, when before trying to persist any data with Kubernetes, you absolutely must go and read how to do it in your specific environment, because use case will be different for Azure and AWS, and you don't want by mistake to terminate and delete and lost data of your clients due to transition to Kubernetes. When you will blame me, don't blame me, I tell you, you do have to investigate that. I'm not covering that right now because there are around, 10 different cloud providers supporting Kubernetes, or maybe mostly probably more, also on-premise, and more ways to use persistent volumes. In the very end, that's a course for developers, and now we speak too much about the operations. Now, hi Vikran. No worries if you've been late today, you always can watch the recording. So, architecture and overview of the application you are going to work with. First, we speak about a very simple application with configuration. So, we have a Kubernetes cluster. We don't care how many nodes are there. And that's not important for us because we speak of how application works. Notice what that's not only about the Kubernetes, but also about the namespace. So we want one application be isolated from another, so it will be just more convenient to work. If we speak from the networking point of view, our first entry point will be ingress. That's the icon to work as to highlight ingress. And we also have a service which is a facade for the group of pods. Those pods are scaled by replica set. I've mentioned it, we don't cover replica set today, that's too much deeps, but it's there. And finally, we define it with a deployment, and this character is a symbol for the deployment. And to set up those pods, we use secrets and config maps. So that's a very typical example of a very tiny, small application, which consists basically of one single service. Second simple application I want to mention today, that's already with a persistent storage. Now it looks kinda a mix of some of the last slides, well, because it is. We still have Kubernetes cluster. We still have a namespace specific for this application. We have ingress, working with service, working with pods, pods scaled by replica set, and replica set is configured by deployment. But now we have some more heroes, persistent volume claim from pods, persistent volumes, and storage class defining this persistent volume. But you know what? Usually it works differently. It starts to look more realistic when we start to have something like that. So, what's going on this picture? Get a moment and try to think on what's going on right here. Okay, so first of all, we have three different services. First one, second one, and third one. And we still have the same namespace and ingress. And ingress works with one and only one service. What does that mean? It means that our application allows external connection to one and only one service, which is kind of a front end for the system. So that's the entry point which receives some queries and processes them. When service on top of that is going to be a database. So it looks like we have three pods here, so it's kind of some replicated database. Doesn't matter, whatever it is, maybe a bunch of Redis. So whatever we use to deploy them. And then finally, we have one more service, which is very similar to first one, which is something which is not open to external visitors. So that's a backend service which is available only for the first services. It's a web service. I don't know. Let's say it's a web application, maybe Python. Why not? And we go forward. Okay, we are ready to go for a live quiz, but I want to cover something bigger before we go to quiz. And I see question: do we get voucher after attending this session? So this session is Monday Learning. That's about exactly this ends Docker learning path. So if you mean voucher, what data stacks, Cassandra certification voucher, no you don't, because we have for that Wednesday and Thursday workshops, and today is Monday Learning. But for those who attend these course and will tomorrow or next few days answer the question of final assignment, we will have Docker upgrade complete achievement, which is kind of a yes certificate. Question: is it possible that pods can communicate each other? One way is through service class or Kubernetes controller. So yes, Kubernetes pods may communicate with each other. Easiest way to organize that is services. Good. Now, a few more things I want to discuss before we proceed to our live quiz. I wanted to show, so that's a Minikube, kind. Mentioned it before. Okay, yes, so I want to do this example with you. That's example from official Kubernetes example. It's a pretty short one, so we will do it quickly. And then you can do other examples on your own. By the way, one more thing from Kubernetes docs tutorials I wanted to give you a link to. I needed Katakodam. Is it here? Nope. Deploy and up. Oh, finally, perfect. So that's the link you can do at Katakoda step by step. Please don't do it now. Stay with me. Hi Japrit. Are the slides uploaded on the GitHub repo? Not yet. I think they will be there in half an hour, maybe a bit sooner. As soon as we will finish with workshops, I will upload the slides. So they will be there in some moments. So don't do this tutorial, you can do it later. Today we work with this one. So it's a guest book, very simple guest book, just database and application, but it will be good enough for us to start and we can go. So this is a pretty interesting example because beside that's like pretty simple one. We just have one Golang application. We just have Redis as a database, so nothing too big. It also not really so simple because, for example, it's going to be Redis with master-slave systems or primary and secondary services. And I'm going to, I have to clone this example, I guess. Give me a moment. So I will have to grab the code first. And second, I'm going to stop our old deployment. So how do I delete as long as I use configuration files instead of deploying services and deployments? Or I can do kubectl delete service my-nginx svc, but I also can do kubectl delete -f and my file, and it will do the same job. So service my-nginx service deleted, deployment.apps my-nginx deleted. Wipe it out and clear again. If I do kubectl get pods, I will have no pods in the default namespace because, well, I just wiped them out. So I'm going to clone this one. Good. I will switch to the examples and I can start to work with them. Good. Questbook go. That's my guy. Okay. So first one we are going to do is we are going to create examples, Redis master controller. Oh, okay. Vikrant asked a really good question. Any easy way to convert Docker Compose YAML file to Kubernetes specific YAML? Let me show you. Yes, that's a good question to answer. And we have some moments to show it because, well, it's a good one. So, can you see my screen? I will make it a little bit bigger. Good. I think you can see my screen. I will switch to my killer video all in one. You maybe have seen or heard of killer video before. It's a demo reference application we use to show how we work with Apache Cassandra and DataStax Enterprise. That's not about that today. The point is to show how can you have Kubernetes definitions out of Docker Compose YAML files. So we have this all-in-one folder. and we have some Docker Compose YAML files here. And I want to create Kubernetes definitions out of a Docker Compose. How does this Docker Compose YAML looks like? It's a very simple one. We just have some services. I will not stop too long on that. That's finally week number 5. So it should be pretty easy for you if you did your homework assignment, of course. So we have some services. And that's, of course, Docker Compose YAML file. So how can they convert it to Kubernetes definitions? There is a special tool called Compose, and Compose with K in the beginning. I don't know how to explain the difference, but I hope you see it directly in my screen right now. So it's not a Compose with C, but Compose with K. When I have convert command and where to put the output, I already have Kubernetes folder, so I will make Kubernetes demo folder. And I don't specify Docker Compose YAML file because by default it will take this Docker Compose YAML file. No such. Okay. Kubernetes demo. Now it should work. Oh yeah. So Kubernetes file manifests created. Some of them. If we switch to these Kubernetes demo, we see here those files. That's basically a killer video converted into the Kubernetes resource manifests. Now that's very important. Compose is a great thing, but there are 2 downsides. First of all, it may need some special configuration for the services you are going to use. You are going to convert. So let me show you. So I will need open recent. All in one. It's a bit weird. But okay. Okay, here we go. So, take a look at this file. This file looks pretty simple, but there are some weird things sometimes. You may find this one. We have services, web, image, port, depends on, environment variable, label, compose, service type, node port. What does that mean? Does Docker uses that? No. Does Docker Compose uses that? No. That's the directive for Compose, how to define service for this container, Kubernetes service. The point is, when you have your port exposed, by default, Compose will create service. So, and for real, if we go here and we see the list of files here, it was web, and now we see what we have: web deployment and web service. So, for example, we may open web service, web service, and see what this port will be automatically forwarded. But problem is, there is no way to explain explain something to use in the Docker manifest, in Docker Compose YAML file, something regarding type node port, because Docker does not operate type node port. This idea doesn't exist for Docker and Docker Compose as well. And here we configure a label which is useless from the Docker point of view in Docker Compose, but it will be used by Compose on the convert type. What service of this one needs to have type node port, not load balancer, for example. Very simple. And the same, for example, for Studio. Very well. So that's the first downside. Your Docker Compose files getting a little bit not so nice Try to keep your configuration as simple and as readable as possible. That makes your application more maintainable. Second point, of course, as in any converter, you may not always fully agree with the decisions of the compose of how it should look like. And for example, here we have some traces. It means what service name web will till the end of the time have annotations compose command, compose service type, compose version. So which compose version we use it, which service type was specified in labels, and which compose command was used to create this file. It's not a tragedy, you would say, and you are right, but I prefer again to keep my configs as small as possible so every line of code will have a big meaning. Not so big problem as it is, because you always can clean up, so I can edit that. I can completely delete some of those services. I don't need Studio. Okay, I can remove Studio. I can remove Studio deployment. I can remove Studio service. I will not use the Studio for this one. It's completely fine. And I can keep making clean up here as well and clean up everything. And in the end, it will be pretty good result. Basically, that's a part of today's homework. Today we have optional homework because of a final assignment coming later this week. But yes, to use Compose to generate your files for Kubernetes resource manifests is one of the typical things that's part of that. By the way, here is an interesting point. Notice what most of the things here have web deployment, web service. DSC deployment, DSC service. Backend deployment, backend service. But generator has only deployment, generator has no service. What does that mean? How it works? Answer is very, very simple. A generator doesn't have service because it's never accessed from other services. A generator is the one who initiates all the other connections, but it never answers the requests. So basically, we don't need service for that. If we go to this file definition and find generator here, it has no ports opened. That's why Compose didn't create a service for that. Another similar but another situation with DSC config. We don't have DSC deployment, or we don't have DSC service, DSC config pod service. We don't have deployment, just DSC config pod. Why? Answer is very simple again. This is a one-time running container pod, as it's a Kubernetes. We don't need it to be executed multiple times. That's why it's created not a deployment, because deployment is something what is going to be long running. But just a pod we can terminate in any moment, and it has restart policy on failure. As soon as killer video DSC config will finish its job, it will just quit, exit code 0, and thanks to restart policy, Kubernetes sees what it not to be restarted. So this one will be empty finally in the end. And when we have these files, we can try to apply them with kubectl. Apply -f local folder. I'm not sure if it will work right now. Okay, it looks not bad, but I got some problems with my local Kubernetes installation. That's why I'm using a web version. I'm not sure if it will work right now, but we can take a look. So we are in the local installation of my Kubernetes. Oh, something is wrong with my audio. I'm sorry, I think I got too close to a microphone, and I'm too excited to show things like that. Give me a moment. 1, 2, 3, 4, 5. Okay, that's going to be better. Yes, I'm too close to microphone. Thank you for warning me. You see, today I work alone, so there is no Cedric to save me. Thank you, Charlie. So, we have those created, and now we can try to take a look if it works or not. So we can say kubectl get pods, and we see what web is running and others are being created. We can ask for deployments, and we see what deployments are in progress. It may take pretty a long time because now Kubernetes worker, first thing it has to do is to download applications, of course, download Docker images, and shame on me, I never had time to optimize them, so those are pretty heavy. Well, okay, DataStax Enterprise is heavy indeed, there are a lot inside, but generator backend could have been better. By the way, if you want to contribute to open source and play with Docker, you definitely could try to optimize something from a killer video. Our team will be very, very thankful because we never have time to optimize them, but it has to be done. Okay. So now others are starting. Okay, I see backend is running already, which is good. And we can try to access web already. So take a look. How could I get some details on a service? Because I'm going to access a service. I can say kubectl get svc. Svc just an alias for services. I can type services. So I see some here. And I can see what web is a type node port. And it's available on port 3000. And as it's available on port 3000, I don't remember how kind works. Should it be at this moment already available in my local host, or I need to use different or yeah, it looks like I need to use another IP address. Kind. Usually we work with native Kubernetes, of course, not with kind. Kind get clusters test. Test. Okay. And nodes. Kind get nodes. Name test. Okay, and kubectl get nodes. Okay, so as said, my local installation of Kubernetes is at this point broken, which is sad. But we were doing another job. So in short, I definitely think I've answered the question about how to convert your files, and we can proceed with the next one. So we are in the examples, and now I'm going to create we are very short on time, so I will try to be very quick. At first, we are trying to create Redis master controller. So we will simply execute this command: kubectl create examples guestbook go Redis master controller JSON. In this case, it uses a JSON file. Well, that very depends on what do you want to have. Redis master controller. Here we go. And that's a replication controller. So replication controllers are now deprecated, and deployment is recommended to use instead of a replication controller. But for us, for purposes of this example, we will be no real difference, except of I should get one level higher. Up. Yes, and replication controller Redis master is created. While it's being created, we can proceed with the next step. And to check if we have it or not, we can simply do kubectl get replication controllers given its RC as an alias. And we have one Redis master replication controller, which is not ready yet because, well, it takes some time to download Redis things. Good. What goes next? We can take a look at the kubectl get pods. And it looks like Redis master is running. That means what, replication controller? Yes, replication controller is ready as well. So we are good to go. Next thing, so I'm suggested to attach, but I will not attach. It will work for me as well. Good. Now I have to create Redis master service. Don't forget, don't try to communicate with pods directly. Very often it's a misuse and you really want to have a service as a facade in front of them. So we go with kubectl create -f examples get go Redis master service. We can take a look at that and notice what's that, Redis master service. So that's very well expected. That's a service, API version 1, Redis master, application Redis, role master. And some specifications for the service. We will use port, target port, selector. Selector, don't forget, selector describes which kind of pods it will become router for. Good, so we can go and execute this command. Service Redis master created, very well. Now we will create Redis slave pods. I'm now going a little bit faster. You can completely go and repeat this process later after me. And don't forget, even when workshop is over, it's not over for real, because we are there at Discord to answer your questions. So we can take a look on how it goes. If we have this RC replication controller running, usually it would be not replication controller but deployment as said. It's not yet ready. We can ask for pods, and it's the same situation for Redis master and Redis slave. They are using different images. Therefore, our workers now are pulling Redis slave images, so it takes some time. And as they are two pods of one different deployment, it means what they have to be executed and created on two different workers, as we have two of them, node 2 and node 3, and as a result they have to be pulled on both of them. Okay, so container creating still. Let's walk through while it's creating. What are we going to do next? Next one, we are going to create Redis slave service. It's mostly the same as Redis master service, with the only difference. Redis master service selector says label up has to be Redis, label role has to be master. And I guess you understand what I mean. Of course, Redis slave service will be exactly the same, except of the role will be slave. So we will have master slave cluster for the Redis. So how it goes for us? Do we have our pods? Not yet. Container creating. Again, doesn't matter too much for me because I can create service in advance. It doesn't matter if you create service after pod or before pod, because anyway, this moment of the mapping them together happens with selector as soon as any new of them happen to be. So it looks like something happened with our master, which is set, and container creating slave doesn't take some time. Okay, we will give it some moment. I can, by the way, try to kill their video and do the same job here. But yeah, kubectl kind is dead. Very, very, very bad. Unable to connect to server. Okay, doesn't matter. I hope this one will work. It's the story of live workshops. At least now you know what it's not a recording, but a real demo. How to view, good question. How to view a pod logs, like we have Docker log container ID. Exactly the same way you have kubectl logs command, but you specify pod by default, and if you need to get logs of specific container out of the pod, basically you do the same job. So the thing you need here is kubectl logs command, and kubectl cheat sheet, and we have logs. So kubectl logs my pod, kubectl -l my label, so get all logs with a label. My pod, that doesn't matter, and you can specify -c which particular container to communicate if you have multiple containers within one pod. One more question from Konstantin Kaplun. Is there a way to orchestrate application distribution between Kubernetes nodes, like prevent collocation all Cassandra replicas on one node? So, there are two answers. First of all, thank you a lot for a great actually question. That's a very good question. In short, when you use Cassandra operator, will take care of the distribution. So it will consider availability zones, nodes distribution, and so on. That's on our side to take care of. If you use just plain Kubernetes and deployment and pods, then Kubernetes will try to allocate pods to all available pods of one single deployment to all available servers. And finally, if you have, if you need to have more sophisticated allocation, that's out of the scope of this workshop, but of course I will tell you. Thing to walk through is call it affinity. Affinity is not the page, is not the part of this page. Okay, so Kubernetes affinity. That's what you need. Affinity allows you to define which node is better to use on which pod, which pod is better to use on which node. Affinity allows you to say, this one is a server with huge possible disk space. I'm going to use that for the pods of the deployment, which will work a lot with a local disk. And this one is the node with a lot of, random access memory and CPU cores. I will use it as an application server, and you set the affinity, and in the deployment you can specify what it goes first, where it should be located. And or for example, nodes, as we know what we create it with labels. We know what labels. Okay, it's still not working. Sorry. We have labels allocated by us to deployments, pods, and so on. But there are some labels allocated automatically. For example, if node is some specific Linux version, you will have this label already allocated. And therefore, you may have some better restrictions, like never run this type of a pod on that type of node. That's a very, very big topic. It by itself deserves a big workshop. So I think that should be fine for us. And you know what? It looks like both of my demo, oops, wrong button, sorry. It looks like both of my demo environments are dead, which is very sad. So I will check it one more time. Okay, local kind is dead. And we have the Docker playground, which doesn't look too nice as well. kubectl get pods that deployments. It has no deployments. Now it has replication controllers. Okay, so yes, these processes basically stopped. Okay, I'm afraid we are out of time. So we still have to run a little quiz, because that's the last point for us today, I guess. Okay, so jump to Menti and we will discuss what to do next at the assignment step, okay? So, I see we have some dozens of people on YouTube and only nine times up on Menti. Don't forget how to use Menti. We go to menti.com and use code 406953. It should be somewhere here. And open just menti.com in browser and use this code to adjust. And that's something better. Otherwise, you know, if we have only 3 people joining, I can send out prizes and close the workshop. But now we are going to have some competition. I love competition. And we have 20 people. So, okay, I give you 5 more seconds to join menti.com 406953. 535. Time is over. Let's start. 22 persons. That's enough to go. 23. Okay. Should I wait for 2 more? So we will have 25 people in quiz. If you never use it, Menti, it's completely open. You don't have to put your email or phone or credit card or anything. You just can put your nickname, and that will be completely enough for us. Good. So we can start. And that's the quiz time. And we are going to play a little game. So, answer fast to get more points. We have a lot of questions for you. Kubernetes. We use Kubernetes for Kubernetes user to manage bare metal servers, deploy monolithic application, orchestrate containers, networks, services, etc. Put ice cubes to fishing nets. Oh, and everyone answered correctly. We have 21 participants and everyone answered correctly. Orchestrate containers, networks, and services. Okay, so if there were no mistakes, who is the fastest? And I see. So Bill was the fastest, getting the first place with 965 points. With just 9 points delay, there is a Pingu. I guess that's a Linux person here. And Paggy, 2 points smaller, sharing the third place with Millie, technically. But that was just the first question, so let's move on. Answer fast to get more points. What is a worker node in Kubernetes? A database node what stores cluster data. The node what runs pods and does the main job. It's a demoted master node. A node equipped with a branch. And time is over. And worker node is the node what runs pods and does the main job. And no, that's not a database node. There is no things like database nodes. Good. Well then, what are the changes? Who was the fastest this time? That's question number 2. And I hope, okay, Adrian was fastest, getting the second place, but the overall result was better on Sartak with 1,929 points, and Gabriel is on the 3rd place. And Lorena is very close on the 4th, so keep fighting. We are getting to the middle. Question 3. Answer fast. What is a pod? Base unit in Kubernetes, logical group of one or more containers. Standalone worker node. Pod is a stateful container. It's an escape pod used to avoid burning data centers. Correct answer is base unit in Kubernetes, logical group of one or more containers. And no, pod is not a stateful container. Pod can be stateful or can be not stateful. That's not the primary feature. So, are there any changes? Winners were correct, but someone were faster, and Lorena gets to the third place, exactly as I suggested last time. Sartak keeps the first place with the only 12 points difference. That's nothing, milliseconds. Adrian is the fastest on this question, getting closer and closer the first one, and Lorena got the third place with Charles and Vikrant very close to the top 3, but very close doesn't mean you are in. Let's go. Question 4 of 6. Answer fast. What is a deployment? Deployment is a kubectl command to deploy a Kubernetes ingress service. Deployment describes container roles. Deployment is a configuration for a group of pods. Deployment is an outdated way to schedule pods. And the correct answer is deployment is a configuration for the group of pods. Deployment is not a kubectl command to deploy a Kubernetes ingress service. You were too much in a hurry and got into a trap. So stay careful. Not only fast, but also correct answers. Okay, so all the leaders from last question answered correctly. What changed? Gabriel gets closer to the top 3 with a minor difference, and Sartak, Adrian, and Lorena are keeping their top 3 positions, and Vikrant is losing them, but still very, very, very close. So that's a tight competition, and difference in points is very small. Okay, that's a question number 5. Not too much left. Answer fast to get more points. To persist data of a pod, we need to do something, Nothing. Pods are persistent by default. Persistent volume and persistent volume claim. Use pod with a special data image. We do not need to persist data. And the correct answer is the second one, persist volume and persist volume claim. Exactly. We do not use pod with a special data image. There is no thing like a data image. And the one who answered it, we don't need to persist data. I'm completely with you. But the correct answer is persist volume and claim. So, what are the changes here? Who was the fastest? It looks like Gabriel gets to the first place with a tiny difference of, 15 points. And Sartak holds the first place. A very good one. So, Sartak, Adrian, and Gabriel. Lorena, you has to keep fighting. There are still chances and very minor difference and only one question left. So, we have to proceed. Question 6 of 6. So that's the final question, and I hope you are doing really well. Warm up, focus for a second, warm up your hands, get ready, watch your phones. YouTube has a little delay, so now don't listen to me too much, but watch your phones, and we go. Now, answer fast. Kubernetes service is required for node management, to persist data volumes, networking, pods, and ingress use service to communicate, to order Kubernetes pizza. Time is up. And the correct answer is networking. Service is required for networking. Pods and ingresses use service to communicate. Correct answer. And not. Kubernetes service is not required for node management. And that was last question. So, what will happen in the top of the list? Sartak gets the first place with 5,778 points. Adrian surely keeps second place, and Gabriel gets very close, just 9 points to the second place, but that was enough to hold the third one. So therefore, Sartak, Adrian, and Gabriel, we ask you to contact Jack Fryer with jack.fryer@datastacks.com, or find him at Discord server and make a screenshot of your victory, send it to him, and he will get your address and send you the prizes. Larina, it was very close. See you on the next workshop, okay? Because, well, it was almost like that, just 2 points difference to the third place. Oh no, sorry, not 2 points. I miscalculated that, but still around 23 or something. 33 on something, sorry. And all the others, don't be sad too much. The main thing you can take away at these workshops is the knowledge, and knowledge is the most important thing. So don't focus too much on these prizes. With the knowledge how to use Docker, how to use Kubernetes, you are getting better and better engineer. It means your salary raises with you, and isn't that great? Okay, so jack.fryer@datastacks.com. I will write you a message. Just a second. jack.fryer@datastacks.com. Like that. And I do congratulate every winner. So first 3 places, you did great for that one. We are not done yet. 2 last things left. Don't quit. Stay with me. First one. Thank you so much. 2 questions. How do you like this workshop, and how do you like this workshop? Is kind of standalone. There is a lot of people who didn't attend the Docker learning path, and I see a lot of people like that, and that's always a big pleasure for us. GitHub for Kubernetes experiments. I will send it all in our usual Docker learning path week 5. So give me a second. So we have Docker learning path. Here we go. There we have content for first 4 weeks, and I'm adding content for week 5 today, or mostly probably tomorrow morning. It's 8 p.m. at my place. I'm in Germany, and my wife is going to be angry if I'm not getting to dinner very soon. So mostly probably I do it tomorrow morning. And thank you so much for joining. That's always a big pleasure. So now I see very positive answers. Thank you so much. And finally, open answer. What would you suggest? Any feedback? You can send many messages, different messages. How was the learning path? It's not done yet because there is a final assignment. How was this workshop? What would you change? What would you add maybe? What do you want to see in the future workshops? Because we are doing a lot of them. Next one is coming this Wednesday, and so on and so forth. How can I install Kubernetes or on CentOS 8? Boma. Short answer, there are 2 ways. First one, you want to have real Kubernetes, like Kubernetes. Then typical ways to do it with kubeadm. Second one, if you want to play with Kubernetes for educational purposes. In a single node cluster is fine for you, use Minikube. If you want to have multiple node cluster, use Kind. Helm chart sounds good. More DevOps technologies. Okay, sounds good. Thank you for warm feedback. I will keep this slide open so you can add more, but we have to move on. And last one, Docker desktop or Minikube for dev-env. So they are different. You need Minikube to work with Kubernetes. And if you don't work with Kubernetes, Docker desktop should be completely enough. Although latest version of Docker for Mac, Docker for Windows included something with Kubernetes. Cassandra. Cassandra is our main topic, of course, so we speak about Cassandra regularly. If you want to subscribe to all of our events, first of all, push the subscribe button on YouTube. And if you want to have better understanding of what's going on with us and which workshops do we run, there is an eventbrite.com, find data stacks. This Wednesday and this Thursday we have workshop exactly about Cassandra with new scalable indexing. Data stacks introduced a new way to index data in Cassandra, so-called SAI, storage attached indexing. Many people say it will work better than all the others types of indexes before. We have upcoming certification exam preparation for those who want to be a certified Cassandra specialist. At workshops like this one, you can get a free voucher to pass the examination. Examination usually costs around something like $200, and you can get a voucher, pass with pre-preparation, pass the exam, prepare with this workshop, and be a certified Apache Cassandra expert for free. And that's amazing. And at Global Cassandra Meetup, we discuss more advanced topics. Moreover, the next guy will be Tej Malipati from Target. He will speak about some interesting things about Cassandra working on Docker at Target. Do you know Target? Target is a big company, so they use Cassandra with Docker, and that's going to be pretty interesting one. And finally, all our upcoming programs from DataStax Monday Learning will appear here. Currently, we're discussing what we will do. So you can push the follow button and subscribe to our events at the eventbrite.com. And final slide. Sorry for holding you for too long, but I always want to explain you everything. Week 5, fifth assignment. First of all, if you were doing Docker Learning Path, I want you to take 1 day of rest because we are sending out final assignments soon, and therefore you will have a lot to do. But if you just joined it for Kubernetes, I want to do Kubernetes related things, or you are very hungry and have a lot of free time, we suggest you to work with Kubernetes using or labs.playwithkubernetes.com, or a local installation with Kind or Minikube, or another point would be, I mentioned it in the beginning, there should be, where was it? Katakoda. If you're attending our workshops, you maybe know already. Okay, that's it. I will copy paste this link again. There are some interactive tutorials. How do you work with an application? How do you deploy that? So that's the... Oh, can you share the link in the chat? Yes, of course. Sorry, I should have done it already without any reminders. Good. And ask questions at Discord. If something doesn't work to you, ask questions on Discord. I've answered some of the assignments of week 3. I will answer the rest of them later on this week. I will record a couple of more additional videos. You may see, you will receive them by email as you subscribe to the Eventbrite. And finally, thank you so much. You are awesome. This workshop, Docker Learning Path, is not over yet. Final assignment is coming. But that was the last workshop of a series. We did a great way out of over 1 full month. And we will meet again speaking about the assignments. In general, this one is over, and I'm very happy to be with you, and more great events are coming. That was Alex Volichnev, developer advocate at DataStax, and I'm very happy to see you here and see you getting better in the engineering. That's always exciting to be more skilled, earn more money, and in general just have fun while deploying different apps. Thank you again, and see you later. Meet you at Discord and meet you in our workshops. Have a great week. That was DataStax Monday Learning.